I want to do projectile motion with all three methods that we have learned. Okay, so a projectile motion in 3D now with no air resistance. That should tell you something. If I'm doing the one with no air resistance today, what do you think we might be doing next week?
One without.
With air resistance. So we did the 1D one before, and we've done this before, right? Where this goes here. And so real quick recap. Three-dimensional. How do we want to call these? Okay, X, Y, and Z. I want to do
This
is
one's
X,
towards us.
this is Y, this is Z.
Yeah, why are you throwing that at us?
I'm trying to catch it. So you're throwing it to me. So we will have V0 as my initial velocity, and this projectile falls on the XY plane. Z is upwards, so gravity will act only in the Z plane. So let's do first. How many equations will I get? Sigma Fx, sigma Fy, and sigma Fz. What will this be? Is there a force acting in the X direction? Is there a force acting in the Y direction? Is there a force acting on the Z direction? What is sigma Fx? Mx double dot?
Yeah.
What is sigma Fy? My double dot? And sigma Fz, mz double dot? So then this gives me mx double dot equals 0. This gives me my double dot gives me 0. And this gives me mz double dot plus mg equals 0. Is this along the I? Is this along the Z? Y and this along the X? What? I, J, K, right? Are they along I, J, K? May I add them? Will I get mr double dot plus mg equals 0?
Yeah.
Do you see how that worked? Because r double dot is nothing other than x double dot I plus y double dot j plus z double dot k. That's how we define them, right? X, y, z. Now I'm combining them into a vector. So let me call this equation A.